very nice dissertation about co-reference and dialogue. He is a senior research scientist at Yahoo now. Before that, he was at Nuance. Before that, he was at Educational Testing Service for several years. I think we're going to hear about all of that today. So,
yep. Hello. How many people are graduate students? How many people are undergrads? All right, cool. Getting a sense of the audience. So I kind of jokingly said like what I did last summer. So the last time maybe many of you have seen me, or the last time I was here, was actually to my defense. So I found these pictures of the defense party, and James, Jeff, and Len. Seriously, you really do look the same. I think I put on a little bit of weight. My glasses are better. You know, here's James making a toast, and there's me really happy this is over. And I think maybe Ashwin's in the background there, so you might recognize. What?
Is that Amanda?
No, that's Melissa Dominguez, who's a vision person. All right, anyway, so that was like 10 or 11 years ago in that room, basically. And hopefully many of you will have the same experience. Some sort of more recent than others, but good luck. All right, so I thought I would just start off. I put together a bunch of slides from different places. And when I went to Yahoo, I had to give a job talk. Usually you kind of say like, well, what you've done. So I kind of co-opted that timeline. And this is not to brag, but just in case you didn't know me, this is sort of my time course in industry. So did my undergrad at Harvard, and I got really interested in pronouns there under Barbara Gross, who was a big AI and NLP person back in the day, and she worked on centering theory. And I took her AI class, and I took her graduate class on computational models of discourse. I was like, oh, this research stuff is pretty cool. And then she's like, well, why don't you do a thesis? And I thought, okay, I'll do a thesis. And kind of like if Barbara Gross suggests something, you usually do it anyway. And so I did it, and then at the end of it, she's like, well, why don't you apply for grad school? I was like, okay, that sounds pretty good. Actually, sounds like she had a lot of influence in my life, but I had some decision making in that as well. I went to Rochester, worked with James, and did pronoun resolution, looking at how pronouns, how you can actually resolve them in discourse and dialogue. Did some automatic affect tagging, with people at the hospital. And I did a postdoc at University of Pittsburgh with Diane Littman, who was one of James's first students, actually. And I kind of switched and wanted to do something completely different. So I did some machine learning, Markov decision processes for spoken dialogue tutoring systems. So given a tutoring system that wants to help a student learn physics, what's sort of the best policy or action it can make at any one turn? So do you ask them like a short question or maybe a deep question, give them some hints, be nice, maybe not be so nice. And so we actually used MDPs to kind of figure that out. And then after that, I got my first real job. I was at Educational Testing Service for about 6 years. That's like a big chunk of time. And if you've ever taken the TOEFL or the GRE or the SAT, how many people have done that? You're welcome. And, and that's something we could talk about a little bit later. But I did a lot of NLP work. They actually have a really nice NLP team there. And I was brought in around 2007. That's when things were really ramping up and started hiring a lot of people from the NLP community, and did a lot of stuff on ESL grammatical error correction, essay scoring, plagiarism detection, short answer scoring, noisy data processing. Ended up being a manager there for many years. And some other things I did was like, I wrote one of those Morgan Claypool books. Dan has one as well. And I've organized this BEA workshop series, which is like now one of the largest one-day workshops in like NACL ACL universe. So if you're really interested in education and how you can use NLP to help that, that's the place to go. And organize a bunch of shared tasks and things like that. Then I was at Nuance briefly. Nuance was starting up like a brand new lab in Sunnyvale. So this is around the time when NLP was exploding, like 2012. All the companies were just trying to hire everybody because they wanted to make the next Siri or whatever Siri could do. And so Nuance wanted to jump on the bandwagon as well. And they thought we need to have like a lab. So Ron Kaplan was the leader of that lab, and I was the NLP manager, and then they had an AI manager, Charlie Ortiz, and a prototype manager, which was Adwait Ratnaparky. So if you remember Maxent, he's the guy that did that. And so we're all working together on making like an intelligent dialogue system. And if some of you might know from NLP conferences, I had an intern, Mohammed Sadi Razuli, and I got him in, and we did a cool work on joint dissolution detection parsing. So doing dependency parsing, but also removing all the ums and ahs and fill pauses and speech repairs. And now I'm at Yahoo Labs, been there about 2 years, and do a lot of different things. probably the overarching statement is discourse analysis for news ranking and personalization. So if you're on the Yahoo homepage, either news or finance, there's a lot of news that gets on there. We're actually trying to like have really high quality news at the top and like personalize the rest at the bottom. And there's all sorts of work at actually doing that accurately for like specific users. Spent a lot of time also my first year there working on like hate speech detection, which you can think of as like standard NLP tasks with like really, really offensive data. Have some work on like parser evaluation, and my intern, who just finished up her summer internship, Ellie Pavlik, did this really cool work on like actually researching formality in online communication. So how or when do people use informal or formal language, can make a classifier to detect that, and can actually use that classifier to support sort of linguistic theories that have been around forever, but never been sort of substantiated with sort of larger data sets. And I do also like a bunch of other work in the community. So I don't know how many people know Matt Post, but he's that guy right there. And he was, I think, Dan's first student. Second? Yeah, all right. He was in there. And so I'm actually collaborating with him and some of his students on doing grammatical error correction, best practices for evaluation and annotation. I'm actually going to be in Baltimore meeting with them on Monday. So a lot of fun stuff. Anyway, that was my life, so I think we're done now. And we just go on having pizza. So there's a couple of talk ideas I had. So I didn't know, I could talk about the formality stuff that's sort of fresh off the press. I gave that talk yesterday at RIT. I thought people might be interested in something a little bit different. I used to give this talk on sort of like how the automated essay scoring engine for the TOEFL and GRE works. So it kind of gives you some insight of like, well, my 6 years of work, but like everything that goes on under the hood for that thing. So that could be kind of cool, and some error correction stuff. What do people, no opinion?
Essay score.
All right, Dan, essay.
Hate speech detection.
All right, I have to find like another slide deck for that. All right, why don't we do the essay scoring stuff? It's pretty chill. All right, so educational testing service. I was actually prepared for this. I figured someone would vote for that. It's actually a nonprofit, and they do a lot of standardized assessments. So the GRE, the TOEFL, SAT, and a bunch of others. So they do a lot of other assessments for sort of state and local levels, and also assessments for other countries. So like Djibouti or like Abu Dhabi would be like, all right, we really want to like revamp how we do education in the country, and ETS is sort of like a policy division that'll go and help them and try to like build things up in sort of maybe a Western manner. And yeah, we have educational tools, so it's not always about grading people's tests, but we also provide like feedback tools such as Criterion or Language Muse, which can like help teachers in the classroom help their students write better. And like I said, there's sort of an educational policy way. So a brief history of ETS. So it's actually been around for quite a long time, about 80 years now. And if you think back, way back then, this is sort of like Depression era, pre-World War II. If you wanted to get into university, you pretty much had to either be wealthy or have like some big name behind you. And so if you're just some like random person whose like parents worked in like the docks or a factory, you were not going to college. That was just the way it is. And there's this one guy actually from Harvard who kind of believed, well, college admissions should be open for all. There's probably a lot of really smart people who just didn't have money or came from those sort of backgrounds that actually would be a great fit for college and would be a great contributor to society. So he, along with two other Harvard faculty, sort of embarked on this really sort of like noble campaign, depending on how you look at it, said like, let's create a standardized test that can actually get sort of like capture this sort of like base intelligence of people, maybe get them into sort of college. And they first did this with the military. So I think like the Navy was like the first to kind of use ETS as tests. And they ended up forming in 1947 in Princeton, New Jersey, which is like literally right across the street from Princeton University. So over like the next 30 years, ETS would pretty much go into the largest assessment institution, and the GRE and the SAT and the TOEFL are by far the biggest tests with like millions of students every year around the world taking them. And around this time, at least like when I took it, I'm Dan and Len, I'm assuming you guys took these tests too, it was all sort of like bubble choices, and if you don't know the answer, everyone would just say put C. And of course, like there's ways you can sort of like be clever, like eliminate two of them, and then sort of like, then your chances are 50-50. There's all these test prep books for that. And around that time, they said like, you know, because of this stuff, and we should actually make the test a bit more predictive. And let's actually get people to write and analyze passages. And so we actually measure different aspects of the thinking, not they're just sort of multiple choice test taking. And so they thought like, let's actually move from the multiple choice to more natural questions. And how many people have actually taken the essay, written essays on the GRE or the TOEFL? Right, okay. Wait, really? Oh, all right. And you can think of sort of like the reasons for this. Well, so if you have a bunch of essays on each test, and like 1 million people are taking that every year, that's going to cost a lot of money. So you can imagine like the human labor that's involved in sort of like training thousands and thousands of people, bringing them in, putting them through a boot camp, making sure they always grade things the same way, and they have like a reasonable level of agreement. And sometimes people like complain like, oh, why are these tests so expensive? And like if they're like graded by the computer, and like there's every test is graded by a computer and a human, and the human aspect costs a lot of money to sort of control and like rigorously kind of regulate. So then you can think, well, can we get machines to do this if you're having 2 humans grade this? And that's when ETS was like, well, we've heard about this thing called NLP. This is sort of like mid to late 90s. And they had one person there, Jill Burstein, who had just gotten out of her PhD at NYU and was like a linguist, but had some computer background because she worked at Bell Labs. So like, what about this NLP thing that we keep hearing about? Why don't you look into that? And so that's how the E-Rater, that's the essay scoring engine system, basically got born. And there's a bunch of reasons why this could be good. Well, there's efficiency. Instead of having like 2 humans, you have a human and a computer, so you pretty much like somewhat half your costs, and you have a faster score turnaround. And then you can also kind of turn this around and be like, well, we can actually make this a market for practice instruction and other assessments, and support like classroom teacher writing. So that's where we are now, sort of like the last 10 or 15 years. E-Rater was born, and Criterion is sort of like the E-Rater version that people can interface with and they get feedback within the classroom. There's a thing called C-Rater, which is short answer content scoring. And there's SpeechRater, which actually does your speech fluency scoring. There are other kind of tools like Language Muse, and we do plagiarism detection because that happens on these sort of like large scale assessments. So automated scoring, I'm gonna like sort of like simplify it here. Basically, you go in an essay, type in an essay, then it goes to this automated essay scoring system, and then it gives you a holistic score ranging from 1 to 6 or 1 to 5, depending on the test. I think TOEFL is 1 to 5 and GRE is 1 to 6. And you really want to make a computer system that automatically evaluates the essay quality and provides that holistic score. So the predictions of scores, just like most NLP tasks, are actually trained on the human raters and their judgments. And one thing, like, I talk to people about this, who maybe like not in the field, and they're like, how do you actually grade the content? Like, how do you know like that fact is right or that fact is wrong? And what goes on is that we're measuring writing quality and not writing content currently. I should say we, like, my former employer, basically. The reason for this is, like, imagine having to fact check everything in a 1-page essay, and you have 2 million essays to go through. Just from the human side of things, that's going to be very, very difficult and going to get very low agreement. So basically, if you're taking these tests, it's all about, can you actually write a 1-page thing that's about that topic? It's on topic, it's grammatically and sort of syntactically sound, you've got main ideas, you've got like an introduction, some supporting points, conclusion. It's sort of like the meat and potatoes, but a lot of people don't do that. And so anyway, so the main thing is on writing quality. So a little bit about history. So ETS wasn't the first one to kind of do essay scoring, though I think they're the ones to do it the most rigorously now. So the first sort of application of this was a thing called Project Essay Grader way back in 1966. And this one researcher showed that we can make an automatic rater that is almost indistinguishable from human raters. But basically, the method that this guy used was length, and length really, really correlates with essay score very well. And I know there's test prep books that have that, and we've seen that in our own analyses. So when we have
the longer the better, or the shorter?
Longer the better. Longer the better. Yeah. And yeah, so any of the features I'll discuss are all normalized by length. So we kind of like dampen for that effect because you could just kind of like write and write and write and write. But the thing is, like, there was sort of like subsequent research on that, and I was talking to one of my longtime colleagues, Martin Tetreault. He's like, yeah, like they found that length correlated well. Then someone wrote a paper that found like the square root of length correlated even better. Then like a few years later, like the 4th root of length was even better than that. And these were like papers. I was like, wow, it's all you had to do was change the N on that. It's like, yeah. Well, that was sort of like back in the 60s and 70s. In the 1990s, when NLP was sort of coming into its own, there was this sort of automatic essay scoring boom. So Project Essay Grade became a full-fledged product. Intelligent Essay Assessor, that was a Landauer's group. So out of Pearson, they did all this LSA stuff. Telemetric, and then E-Rater, pretty much. Okay, so E-Rater. There's no questions so far or anything?
Well, I'm curious about the topics that are prescribed in these essays. I mean, are the raters looking for topical coherence, or adherence to the topic that was prescribed, and what kinds of topics are used?
Well, all right, there's a lot of questions there. So each topic, there's maybe like 400 questions that the essays that are actually on the GRE website. So you can actually see what all the questions are beforehand. The thing is, there's so many of them, there's no way you could actually prepare for all of them. And so if I remember correctly, the rubric is like you have to answer that question, so you have to be on topic. And you should be sort of coherent within the essay as well. Does that answer things?
Yeah, so each of the scoring systems has to somehow adhere to the topic. Right?
Exactly.
So you can't
Yeah,
have one and the same algorithm on all of the essays.
Oh, right. Yeah. So I'll get to that in a little bit. Okay. Yeah. So some stats here, like ETS. This is sort of its most mature NLP capability. And like circa 2010, I'm sure this stat is even higher now. There's sort of like 5.8 million submissions to E-Rater. And now I think roughly they're averaging over 1 million like TOEFL essays and probably more than that in the GRE at this point. And just to kind of say, like, I mean, sort of the take-home message is, well, people ask like, oh, is this as good as human raters? And it must be if you're kind of using this operationally. And the answer is pretty much yes. So it's pretty much the same. A computer and a human agree as much as two humans agree. So the TOEFL is measured on a 5-point scale, and 75% of the time, the E-Rater machine is going to get the same score as the human. And 98% of the time, it's going to be plus or minus 1 point away, which is sort of within the allowable epsilon. That means sort of like 2% of the time, it might be like 2 points away or 3 points away. In those cases, like a sort of an adjudicator is brought in, another human, to kind of figure out like, all right, let's see if which one's actually right, and to give them an average score or like select one score. So the main thing that drives all this is the features. So you have the automated system, essay scoring system. They have a bunch of features and a bunch of essays, which is sort of like your training data. And you have training data for each question. Things, the main thing. So like you have a model for each of those. You have like 400 models basically. So you have scores for each prompt. And we're going to give a holistic score, but because we have all these different features, we actually give sort of like some holistic feedback as well. So think of it as sort of like a massive like regression suite of like 50 plus features that measure like pretty much sort of conglomerated into 11 high-level features. And each feature is represented by like a module. So we have some modules which are really, really simple. Like they're like pretty much manually collected rules, regular expressions that would check for like typos, maybe like subject-verb agreement, things like that. There's like some that are like much more complex, and these are sort of like the more researchy ones, where you have to use NLP and machine learning, where you're like, shoot, like, how do you decipher what the best preposition to use, or if this preposition is correct, when you have like 25 prepositions to choose from? And some of them are kind of okay, some of them are better than others. This again, like combined, sort of similar to a lot of work sort of during this time, it's like combined using linear regression. I think Watson uses the same thing to produce a holistic score. And now, like one thing is, you could say like, Joel, well, why don't you use like random forests or like deep learning or things like that? And part of it is simplicity. So it's one thing to get like the best score ever. It's another thing to make sure it's interpretable. So when ETS actually says like we're deploying a new test for like the state of Virginia or something, if something goes wrong, we have to be able to track back and explain what happened. Or if a lot of things go right, if we're trying to get a new client, we have to say like why this gets right, why some features are weighted more than others. And some machine learning methodologies are easier to do than others on that. The regression one is like one of the more straightforward ones. Yeah, so I think I said this before, E-Raters train on holistic scores from the human scored essays. The human raters adhere to a rubric, and these rubrics are designed by sort of educational PhDs and professionals. It's not like computer scientists are involved in any stretch of imagination. We depend on them to tell us what's right or wrong. And so E-Rater features are basically tasked with like matching those rubrics, just like the human scores would actually have to like judge an essay based on those rubrics. So the following features are here. So we have grammar, usage, mechanics, style, and organization. So those are maybe more mechanical in nature. Development, which is more discoursey. So like positive features, which are one of the newer ones I put in right before I left. We have lexical complexity. Then we have topic-specific vocabulary usage, which I think goes to your point about being on topic. And we also have a bunch of filters to make sure people don't try to like spam the system or do something nefarious. So I'm gonna like give some examples of each thing here. So on the grammar side, I mean, you could think of some things, well, spelling, sentence fragment detection, garbled words, subject-verb agreement, motel R, that would be flagged. verb form, they are need to distinguish, pronoun errors, and there's like a bunch of these all within this category. And so what each module will do is say, like, every time it sees something wrong, it'll just, you know, uptick a counter for that sort of like node in the vector.
So there's a parser.
There is a shallow parser, which just does sort of like really shallow noun phrase and verb phrase trunking. And part of it is, I mean, I don't know if they're using a parser now, but when I was there, they did use a shallow one, and it actually was pretty good for, especially for GREs because they're well formed. But at the time, there's like each essay had to be processed within 2 seconds. So if anything is going to take too long, it's going to throw it out. There's also usage errors, which are, I think, some of the more interesting ones because they require a lot more natural language processing and machine learning. So you have incorrect article or preposition, sort of confused words like affect versus effect, or dear, D-E-A-R versus dear, D-E-E-R. Faulty comparisons, double negatives, things of that nature. And of course, like some of these, you can probably like put together some regular expressions quickly. Other ones, you have to have like full-fledged models. Mechanics, so spelling, punctuation, capitalization, missing hyphens, apostrophes. I had like an intern a couple years ago work on actually comma error detection in TOEFL and GRE essays, and we used like a CRF model to like, you know, look at each spot in the sentence, say should there a comma be there or not, and you know, did that at pretty high accuracy. And then there's style, so like people sometimes write 2 short sentences, maybe 2 long sentences. Sometimes people just repeat the same word over and over again when they should use a pronoun, or maybe they use too many passive constructions. And then some of the more complicated ones with the discourse stuff. And so this was sort of like a name of getting at the argumentation of the essay. Like, are things structured well? Are there main ideas? And for that, we look at sort of discourse sequences that are extracted out of Daniel Marcoux's RST parser from 2003. And that works fine, but it's not perfect by any stretch of the imagination. And that's sort of like an ongoing challenge in this field. So if you want to know how to game the system, when E-Rater first came out, this would have been like 1999 or 2000, and they put like a beta version on the web. And it's just kind of like, this is it, like, you know, kind of like so people can play with it. And of course, the people that play with it are all journalists. So all these journalists jumped on the system and then started typing gibberish and starting like putting in like Shakespeare's, you know, sonnets and stuff, then putting in like some really good like Churchill speech. And lo and behold, like those things would get like a 3 or a 2 out of 6 because the model just wasn't trained on them and it's not supposed to rate poetry. Then people would say like, aha, well, this is really, really bad. You should go back to the drawing board. And so that was sort of a little negative press, but they persevered. And to kind of counter that, like a lot of the people went back to the drawing board over the next couple of weeks, made just a lot of like detectors. There's something called word salad detector where people just kind of like bang on their keyboard, and you know, if there's enough spaces and like interesting words, maybe you can actually get some non-trivial scored out of that. So they made a sort of a mini classifier that will actually check for these types of phenomena. Another one is unusually short or off-topic essays. So these are actually things that people typed in their essays. I mean, these are whole essays, to be honest. This should have been a page. So I don't know how to explain this question because I took a nap. Sorry. And then this one is all caps. I think everyone should be able to wear whatever the hell they want to wear. I mean, they got their message across. So like, no discourse analysis required.
Nice, like, concise.
Yeah, no, exactly. And it's completely grammatical as well. So these were actually like sentences, actually full essays I found in the TOEFL. So there's kind of like flags. I mean, these are easy to design that looked for like, you know, things that are topics. You can use LDA or LSA to kind of do that and just look at kind of the length to make sure that things are looking okay. The thing is, in practice, I work, you know, with Jill closely. We're both like the senior scientists there. And I remember like giving this talk and I was like, Jill, how often does this actually happen? And because people, you know, I always ask that question like, oh, how can I game the system? Can I write it like this? And can I like cut and paste Wikipedia articles and pad my thing? And she's like, the things that people worry about maybe happened 3 times in the last 10 years. It's very, very rare, just because these tests are high stakes. So, I mean, why go in and like have this test secure, pay like $100, $200, and then go and just try to like, you know, finger bang or whatever through the system? It's kind of like not really worth it. So it really, really rarely happens. But at the same time, it could happen.
Question?
Yeah.
Like, how do you address like long-term trends that occur? Like, I think it was like a peak around 65 and then went down for a long time and then just come back up again or something. But how do you assess whether or not those differences are due to the tinkering you do year in and year out in addressing the metric versus changes in the educational system of what the students are actually being taught?
Yeah, that's a very good question. I know there was sort of like right when I left, and I'm kind of like, I don't want to like punt and say like, well, I don't work there anymore, so I'm not going to answer this. But like, right when I left, they were sort of like doing a major revision of the GRE and to kind of like revamp the test because some questions like the analogies and the antonyms were just not predictive anymore. Like these were things that have been around for decades. And part of it was just like, they were kind of like, after a couple decades, you're pretty much done, gone through all the pairs you could possibly done or ever do. And also like, we found like this one site in China that had like all of them saved. And it was like this gold mine, sort of looking at the Chinese students, they're like, I know what you're talking about. And where people would just go and memorize it. And so it starts losing its predictive value. So they'll remove questions. So every kind of year, they'll actually check to see which ones are actually predictive or not, just by themselves. Because that's going to really make or break the test, right? If things aren't predictive, then why use it? And then every year, they also retrain the models. So we also get the human annotations, and for all the questions, we actually just retrain with 1,000 essays every single model, because language does change, and how things, the rubric may slightly change. But in terms of your other point about like, well, the educational system might change as well. Yeah, that requires like more like large-scale revamping, and that's what the new GRE was about.
Right, because I mean, wasn't it true that for like a couple of decades, I mean, like the scores went down?
Yeah, yeah, and then they kind of recalibrated things.
Right.
Yeah,
And
yeah.
so there was an issue. One of the two had to be either the way you rate was out of match with what was being taught, and what was being taught was wrong, or what was being taught was right, and your metric distance out.
Yeah, that's the thing.
Like obviously, over 20 years, the genetics aren't going to change.
Yeah, but definitely how people are taught are gonna change, or how students react.
More people started taking essays.
That's
Yeah.
the other thing.
Yeah.
I think it's a different demographic.
Yeah, so I mean that was sort of like a whole other division, not to punt, but like this was a thing that was always like we were like a small NLP group of maybe like I think it's like 20 people now, which is actually pretty good for a company. But ETS research I think is about 300 or 400 people, and 200 of them were this psychometricians, which is a whole other field which I never heard about until I got there, which are statisticians who specifically work on educational measurement, and so their job is to kind of make sure that every 6 months or every year, like everything is sort of ticking along in place and, reacting to kind of policy properly. So you can think about like E-Rater, well, you have all these great features, so one thing you could do is actually just flip it and say like, instead of just giving like one score, well, you can actually tell the students what they got wrong and what they should change. So that was where Criterion came about. And what happens is a student will work in the classroom, and a school will actually buy a license to the software. And you go to your computer and you go in the browser for E-Rater, and every student has an account, and they have a portfolio that the teachers would set up. So a portfolio would consist of all the essay prompts they'd have to write over the semester, over the year. And the student would actually sort of submit their essay to the system, go to the ETS servers, and come back, and it would sort of highlight everything that was wrong in sort of like those like 5 or 6 main categories out of the 11. And so E-Rater could either get a holistic score or get this sort of like very specific writing analysis feedback. So here's sort of a screenshot of things of kind of the old interface. And basically, you would highlight different things. This is kind of like one category is repetition of words. So I saw that, students and clothing was sort of mentioned a lot for such a short essay. Like, you might want to use synonyms to kind of like make things a bit more diverse. You can kind of see the tabs up there: grammar, usage, mechanics, style, organization, and development. Here's another one where this is actually doing the discourse structuring. This is again using Markov's parser. So the blue one is the introduction. The red one is what it thinks is sort of the main idea, and like sort of highlighted. And it says like, is this part of your thesis? If so, it's great. If not, maybe do something. And then you actually have like main ideas for the supporting paragraphs in the conclusion. And that's a really, really hard problem. And this example looks pretty much okay, but in longer tests where like people may have like more creative like structuring, it'll get a little messed up. But this kind of gives you an idea. So I like to tell people it's sort of like Microsoft Word on steroids, because we do a lot of different like ESL errors that Microsoft Word doesn't do, but also a lot of like discourse level stuff that MS Word wouldn't do. And so like, how do teachers use this? Well, there's a couple ways. So one way is just like, all right, keep iterating on this and submit it when you're done. But the most common way that teachers use this is that they'll tell their students to keep working with the ETS system until you get about a 4 out of a 6. Because I know all these sort of low-level errors like articles and whatnot are going to be out of the way. and that the stuff that gets you from a 4 to 6 is probably a bit more complicated, even for a machine. And that's where like I'll have to go and intervene and really like sort of teach things. So it's a way of kind of saving teachers time in the low-level stuff, which a computer can do fairly accurately, and the teacher can do the more specific on like writing quality and writing content. So that's sort of like the E-Rater system in a nutshell. People have any questions? Yes.
I'm wondering about, so you said this, if people get creative, right, then it trips up. There's, there's kind of a formula. And I'm wondering how that interacts with the predictive aspect. Right? You have all these people testing, trying to figure out whether what you're doing is predictive. And that seems to conflict. Is that something you guys worry about? Right, because I would think, you know, coming up with creative solutions, that could be something you want to find out.
Yeah, that'd be great. And that's a really tricky question. Basically, when you take, so in this case, the student is just in a classroom, and the teacher may have like certain expectations of how the essay should be written. Maybe it should be five paragraphs, maybe it should be 5 pages. And so they might actually turn the discourse thing off if they feel like it's going to be bad. For things like the GRE or the TOEFL,
I guess it's more.
Yeah. Then it's a little bit trickier. I think the expectation is, and this might be in the guidelines, is like you really want to write a 5-paragraph essay and have it be a page. And like if you're a really good writer, I think some people just sort of back off from kind of writing the most flowery thing ever, where it's like maybe your introduction comes like 2 paragraphs in, or your thesis. I remember writing papers like that in school, and it's clever, and I think like a human would probably get that, the computer wouldn't do as well. But that's why we actually have the checks and balances. So the human will definitely see it, probably give it a higher score. Machine might give it like a point lower or so. And then, you know, another human may come in. But I don't think that actually happens that often, to be honest. Like the good writers are gonna kind of like have like an introduction. But I remember giving this talk in Edinburgh a couple years ago, and there was this one, he was a computer scientist, but taught a lot of like undergrad classes. And he got really, really angry at sort of the fact that this was going on, because in some ways it's sort of controlling language. Because you're kind of being like, this is exactly how you should write. And in other cultures, this sort of 5-paragraph thing isn't like a thing at all. So that's kind of sort of a problem, but most American universities expect this sort of stuff. At the same time, this is sort of like a base level of writing. We're just trying to see like, all right, can you actually put together an argument and write things that are grammatical? And so it's not like we're expecting you to write the most glorious piece of writing in 30 minutes ever. We just want to, do you meet the minimum like sort of levels?
So I wonder if the predictive part is actually your ability to play the game, so to speak.
Yeah, there's a bunch of it in there. Yeah. So like, there's nothing that's going to like, ooh, look for that sort of really creative essay. At least when I was there, there might be something now. So one thing I want to do is maybe talk a little bit more on the NLP. And again, this is maybe a little bit dated, but gives an example of what goes on under the hood. So I spent a lot of time working with Martin Tetreault, who's a professor at CUNY, sort of a psycholinguist, but he's been moonlighting as a computational linguist since 1980, and did a lot of the early work on E-Rater and grammatical error correction for non-native speakers of English. How many people are non-native speakers of English here? Okay. Yeah. And so this is for you. But so like one of like the sort of fast-growing fields, and this has been kind of a hot thing in the NLP community. Well, not as hot as like deep learning or sort of things like that, but in terms of like tasks, is sort of like NLP for these ESL error correction sort of populations. And right now I can throw out some statistics about like 1/3 of the people in China alone are actually learning English. 10% of the students in the US are actually learning English as a second language. They're coming in from other countries. And there's a lot of sort of like pressure on teachers where they're like, not maybe like when I was in school, everybody spoke English. Granted, this was Vermont. But now like teachers is sort of like, you know, California and the South and some big metropolitan urban areas, they actually have a big student population where the students are trying to learn math, but they're also trying to learn English at the same time. And that's sort of like another load. And there's another thing where there's a lot of people like actually, since there's kind of this need for a lot of teachers to teach English, either in Asia or Europe, but also in America, there's also a need to make like quick assessments to actually see, is this teacher actually fit to teach? And so people thought, well, we can actually do NLP with this. And ETS isn't the only one to do this. I had some colleagues at Microsoft Research, Michael Gammon, Bill Dolan, Chris Brockett, around the same time I was at ETS. They had kind of a competing sort of system called ESL Assistant, where they did like articles and prepositions. And actually we sort of at the same time pretty much made the same types of like models, classification models. And they had a web-based thing where like people could go in and type their sentence, and Microsoft ESL Assistant would kind of flag like specific errors, like these ESLE type errors, and actually show a pie chart with some Bing results about like what sentences would look right and wrong to give you like feedback. But they pulled that project sadly in 2011, so that website is no more. There's other kind of publishing assessment companies, like ETS is not like has a monopoly by any stretch of imagination, but it is very, very large. Pearson is a very large one. There's like a big one coming out of Cambridge that Ted Briscoe works on, and there's Oxford. There's also some smaller companies that have come up the last 5 years. So Grammarly is probably the best known in terms of giving like grammatical error correction feedback. And they do some like really minor NLP. There's like White Smoke out of Israel. In academia, there's like UIUC. So Dan Roth had a student, Alla Rozovska, who did a really nice dissertation on this stuff. There's a bunch of other places that sort of actively work on this. And I kind of feel like, a field sort of starts coming into its own when there's a shared task. Like, so when I started getting into it, like everybody had their own proprietary data set. So we'd publish papers, but like no one knew who was better. Like I could claim, well, we got 80%. Microsoft says they get 70%, but they have a completely different data set. So who's to know who's better or not? So Robert Dale and Adam Kilgariff made a helping our own shared task where they took papers from the ACL anthology and actually had editors go in and actually correct them for grammatical errors. And actually these were papers submitted to the anthology, sort of like when they're doing the mentoring thing. And they used that for like a early shared task, and then they expanded out. And then Huitu Ng at the National University of Singapore organized the 2 Connell shared tasks in 2000 and 2014. So there's a kind of a lot of interest. I feel like when you get into the Connell level, that's a pretty good sign. And there's a whole session at ACL 11 devoted to grammatical error correction. Oh yeah, all right, so I want to do this little audience participation part real quick. All right. Wait, that didn't work. If I just slide this over. Okay. This is like my first 2 months with a Mac, so I might need some help with this. I just kind of want to put some examples up to sort of underline how challenging this problem can be. So these are all sentences that I found in the TOEFL, and I've got a bunch of them here. So if you see the sentence, nothing is absolute right or wrong, how would you correct it? Okay, cool. All right. Oh yeah, that's an interesting one. I've never heard that one before. You put a question mark there. And how about the second one? He is fond of cats. No, there's no dog lovers here. Let's go to a little more complicated. All right, so how about this one? Social network plays a role in providing and also filtering information.
It's totally correct to me. I would write that.
In the right context, I think would be correct, but otherwise, it also kind of seems a little bit redundant. So I could think of a situation.
I mean, it's, you can't have a bare singular when it's a count noun.
Yep. Yeah, that was the thing that kind of bugged me about that. Yeah. All right, let's go do another one. Let's skip that one. All right, let me just try to slide this over. All right, I arrived in time, and the musical show started late, so I was getting nervous because I did like very much the impunctuality. Well, we could take it sort of like one clause at a time. So I arrived in time. People are fine with that? All right. I guess you can also say I arrived on time, depending on how you want to interpret the meaning. And the musical show started late. How do people feel about that?
It's grammatical, a little weird.
Yeah. How would you fix it?
Just take out musical.
Okay, and the show started late. Yeah, sort of an awkward collocation, right? You kind of understand it, but it wouldn't be necessarily how you phrase it.
But there's lots of shows that aren't musical, so
Yeah.
I think it adds content.
Yeah.
But normally you wouldn't specify it in that way. You'd specify it in some other aspect of context.
Yeah. Or it could be like a musical, so you just use musical. Yeah. So yeah, we don't know, there's no context. But you can see like it's a little bit tricky. So if you just have a show, like James says, you drop a lot of information because then it's, what is it, cabaret, I don't know. And then so I was getting nervous, that seems fine, because I dislike very much the impunctuality.
The object should come right after the verb.
Yeah. So how would you rewrite it?
Because I dislike impunctuality.
Yeah.
Very much. And
Yeah,
they-
yeah.
These
Normalizing
shouldn't be there either.
normalizing punctuality is rather bizarre.
Yeah, yeah. All right, we'll do one more. Let's see here. Skip that one. Yeah, this is a classic. So in Conscient, for some reasons, museums, particularly known travel place, get on many people.
I don't even know.
Dan, if you can't do it, how can you get the computers to do it?
Conscience?
It's supposed to be in conclusion. Yes, that like so like I've looked at this and
All right, in conclusion.
Yeah,
Yes, all right, yes.
all right, so let's just assume it's in conclusion.
Definitely known travel places would fix that.
Yeah.
Get many people. Get on many people. I don't know.
I've never observed that.
It's a light verb with no idea what it
Yeah, yeah. So
means. Annoy maybe, or I don't know, or
Or is it just that many people get to go there? Is that what they're trying to say?
the interpretation I have is that in conclusion, for some reasons, museums and other well-known sort of like tourist attractions attract many people.
Yeah, exactly.
Yeah. That was those sort of like, I've looked at this since 2007. We found this like gem when we were trying to do parsing and grammatical error correction, and this was a doozy. So anyway, these were all real examples from people's TOEFL exams. And yeah, so this is the kind of stuff that a computer is going to have to deal with, basically. And we saw some examples of sort of preposition errors. Let me go back to my slides. All right, how are we doing on time?
You have 21.
Okay, all right. So anyway, one thing that we were working on at ETS was sort of like preposition error correction. And this is sort of a challenging one for non-native speakers of English in like certain different cultures. And we wanted something that could be used in the E-rater system, but also provide pretty high quality feedback to language learners. And so it's kind of like three types. You have your selection errors, where you use the preposition in the right place, but you use the wrong one. They arrive to the town should be, yeah. And extraneous use, they came to outside should be, yeah. And omitted, yeah, he is fond of this book should be, oh, good, all right. We're all doing well. Yeah. And so the motivation here, well, yeah, it's one of the most challenging. There's like some previous studies that showed like, 18% of sentences from ESL essays contain at least one preposition error. In our data alone, we estimate there's about 8 to 10% of all prepositions in a TOEFL essay on average are actually used incorrectly. And so why are they so challenging? Well, there's a couple different reasons. Prepositions sort of like actually have so many different roles. So a preposition can appear in an adjunct, and that's sort of constrained by its object. You would say on Friday, but you wouldn't say at Friday. You'd say at noon, but you wouldn't say on noon. Sort of conversely, prepositions can also be used to mark the arguments of a predicate. So like fond of beer, but you, yeah. I guess you could sort of say fond for beer. No, fond of beer is a lot better. I've read too many TOEFL essays, and now my language models begin sort of get degraded over time. And sort of like to make matters worse, you have things called phrasal verbs, which are like, you kind of look at it, it's like two prepositions back to back. There must be a typo there. You just have to remember, like, give in actually means to acquiesce or surrender. Yes?
Is TOEFL ever tuned for the native language? I was thinking of, like, I corrected a thesis of a Finnish speaker once, and the articles were gone.
Yeah,
It's
yeah.
very hard to edit, so I would read the sentences backwards.
That, yeah. No, that was one thing I was trying to get off the ground because, different L1s make different systematic errors, and like some languages totally drop the articles or just misuse them, and like some people like do different sort of preposition type errors. And the thing for us was just having enough annotated data within each L1. So we actually knew what each L1 was. In TOEFL, you have to kind of put where you took the country, what your native language is. It was actually fairly reliable. People don't lie on that. So we had a lot of data, but it was just wasn't annotated, basically. So yeah, there was like a shared task I made a couple years ago, which is the native language identification shared task. Basically, given like an essay, written in English, can you determine the speaker's native language out of like 11 different L1s? So yeah, that was a lot of fun, and like I think the best system did like 80% or 84%. But that's a really good thing, because I was trying to get that going, because if I had like a model for German and a model for Spanish, model for Chinese, then I could kind of just tune things accordingly. But yeah, there's limitations with these things. Another thing is sort of prepositions can appear in actually, multiple prepositions can appear in the same context. Here's a sentence from Microsoft Encarta. When the plant is horizontal, the force of the gravity causes the sap to move, some preposition, the underside of the stem. So this is like the final audience participation part of the talk. You have 4 choices. You have to, on, toward, and onto. Like, I know there's some context to this. It's sort of a very specific biological thing, but ignoring all that, like, take your best guess of what the writer wrote. How many people think it's to? So we have
To or toward. I don't think
Toward.
yes.
all right. We have a couple of people who are about to. How about on? How about toward? All right, we got about like half the crowd likes that. How about onto? 1, 1.5. Kind of feeling it out. So the writer actually used to. Our system said on, and then we had two kind of like masters in like sort of liberal arts research assistants who would actually do a lot of our grammatical error correction. And so they had been doing preposition error correction and detection annotation ad nauseum for like a year. I think we burned them out. Never used prepositions again. But Rater 1 gave toward and Rater 2 gave onto. And so you could just look around the room, it's a disparity in results. So you have the system that kind of, there isn't just one thing that's right there. There's a couple things that can also feel right. And I know this is sort of a,
Part of this is you got to use your common sense knowledge.
Yeah,
I mean,
exactly.
I'm just eliminating on because I know that sap moves in stems. Unless the plant's cut and it didn't say anything about that, there's not going to be sap on the stem.
Exactly, yeah.
So that's sort of a knowledge thing. It has something to do with language.
No, that's exactly true. Yeah, it makes it also very tricky. Yeah. Yeah, this is sort of a loaded example because of that fact, because there's sort of no context and you're sort of using your best guess. But and there's also a couple of prepositions that sort of fit.
If it said ant instead of sap, then it might be.
Yeah. Yeah, exactly.
Hey,
Yeah.
so
Yeah. We'll use that for the next time we give this. So, this is a pretty standard NLP methodology. I'll kind of like fly through this. So at the time, this is kind of like, people you're sort of saying like, oh, MaxSense old-fashioned. Well, pull
I'm
out the
not saying
slides.
that. People
Well,
are.
it is. But it's kind of standard system flow. So you put in the essays, you do some pre-processing, the tokenization part of speech tagging, we have the shallow chunker, and then we do the feature extraction, generate the preposition features, train up a model, send it to the model, do some little filtering on the model because there's some things that wouldn't get quite right. Then we'd flag it's an error or not. So we basically want to say error or not. And the features, So what we do is we didn't have examples at the time of kind of like examples of errors and examples of sort of correct data. We just had examples of correct data. And so what we do is basically train a model of correctness. So we have like 36 prepositions that we look at. We basically said, let's find all the prepositions that appear in several million TOEFL essays, part of speech tag it. There happen to be 36. So given a model classifier in context, we're going to output a probability distribution over those 36 most frequent prepositions and compare the weight of the system's top preposition with the writer's preposition. So if they differ, well, there's probably an error there. But if they're the same, okay, that's probably some validation. So an error occurs when the writer's preposition doesn't equal the classifier's prediction, and we also have a threshold. So this is sort of like what we had to do when we didn't actually have positive and negative examples. We try to do our best guess. The good thing about doing it this way is you just have a lot of well-formed text you can look at. And so the limitation is sort of like how many sparse features your model can take and sort of how many gig your machine can take. So developing a training set for error-annotated ESL essays, a little bit too intensive, so we went with this how close to correct the writer's preposition is type model. Now I should note now, like this is sort of an older talk, just to give you this is exactly the model that's in the ETS system. But since then, like about 3 years after we did this work, a bunch of data sets came out with the Connell share task, so people could actually train. ETS has released some data. So things have sort of moved forward. At the same time, we also had like, my colleagues and I had a paper at NACL where we went and looked at Wikipedia revisions and actually just scraped all, like anytime a preposition was changed to another preposition from the entire Wikipedia and said like, all right, we're gonna use this as training data because it's free, maybe a little bit noisy. And then it actually worked out pretty well across like 3 different ESL domains. So things have sort of moved forward past this point, but this is kind of what the state of the art was back then. And this, actually we entered this system without any tuning at all into the Connell share task, and it finished like a close second or third to like the top system from Illinois. Just kind of used it out of the box, maybe like change a little bit of the weights. And they were training on actual negative and positive examples. So the feature selection, so if you're kind of designing this, should be able to have for a lot of you, the preposition influenced by, well, the words in local context, how they interact with each other, sort of the syntactic structure of the context. There's also sort of like, as James said, like we kind of have this knowledge of how the world works and like things move up or down, and that can influence like what the preposition is. Of course, it's really, really hard to capture in these types of models. So we just hope for the best, and maybe the other two could actually sort of capture most of, get you most of the accuracy. So we do some feature extraction, part of speech tag, heuristic early on, but there was sort of this kind of like system limitation, practicality of like it running too slow if we did this for everything. But I did have a paper with Jennifer Foster from DCU where we actually tried it, and it does improve performance a little bit. And actually the Stanford parser is fairly robust to a lot of the idiosyncrasies that you see in ESL data. And at the end of the paper, we do analysis of like what trees work and what doesn't. But usually, like around the preposition, it would actually get the dependence fairly right. And so feature extraction, know the words in the plus or minus 2 word window. We actually try to extract the head noun, the following noun, the preceding verb phrase. Those are very influential features. And so, yeah, I mean, these are pretty straightforward to do. And then, so evaluation is a really tricky thing. And it's like always not a very sexy talk to talk about evaluation and annotation. Like here are the annotation standards and people's eyes glaze over. But it's one thing in any NLP field you have to take seriously, because I feel like a lot of people now will go and like write their ACL paper and they'll use whatever data set is there and say like, this is the one we're using because someone else used it. But a lot of them have problems. You sort of have to take that into account as a researcher. That was sort of a really big issue with error correction, where the data sets that are coming out of the kernel were actually annotated by only one person. That person was not a native English speaker, and so they missed some of the corrections. And so there were like kind of holes, and like some people were like, well, we actually would have done 10% better if all these things were fixed. And so at ETS, we did a lot of work into looking at like having multiple raters, what are efficient ways of actually collecting this data and still getting reliable data. And there's also issues of performance thresholding. And so evaluation, like I said before, there's all these different corpora. So if you have a sort of data set that was written by like, junior high students in Korea, it's going to be very different than sort of a data set from like college students learning English in sort of like France. And one paper that I was sort of working, we had at ACL in Beijing, where what are the best metrics to use? So this is work with Matt Post and Courtney Nepolis and Keisuke Sakaguchi. Matt Post was Dan's student again. And all those guys are JHU. So there's a couple metrics that the error correction community has used that's sort of like this weird like sentence alignment thing. So you have the corrected sentence, you have your source, but you also have your reference. And they would use like dynamic programming to kind of figure out like, all right, how many corrections were made. And what we found was that the two metrics that everybody have used, one of them was negatively correlated with human judgments. And they had a NACL paper out of it. And the one that was used in the shared task, blue actually beat pretty handily. And then we made like a weighted blue. So Matt's like an MT eval and MT guy, so sort of borrowed from that community. And that actually did the best. Yeah, so that was kind of surprising. It was just like, all right, people are using these metrics, and some people can like, oh, like we're the best system, but you have to take this into account. So in the paper, we actually show like what was the best system actually drops to 5th, and what was actually like in the middle was now like 1st or 2nd, and can sort of make a big difference for how you interpret results and how the field moves forward. So sort of wrapping things up here, we have a training corpus. We actually sampled from a news corpus. But also ETS had access to all these, like a huge corpus of 11th and 12th grade texts. Yes?
So in the previous slide, you said the L1 language background kind of, significantly influences what types of errors they're going to be making. Mm-hmm. Is it possible, given in non-native English text, to kind of infer the L1 background of the speaker who wrote it? Yeah. So there's actually the task I was talking to him about. So given an essay, can you predict the L1? And you can do that, like, I think the best system does 84% now. Word engrams, character engrams get you like most of the way. That's pretty much it. That's sort of the take home. But there's like Google NLI shared task, and like there's like 30 teams that actually NLI, native language identification. Yeah, there's a page for that. So we have a training set, and then we have a test set, which were actually annotated TOEFL essays. And we did some annotation. We actually had them done by 2 raters. See, the agreement is pretty high. It only looks high because most prepositions are correct, like 8 to 10% are correct, but the cap is around 0.6. We could never get it above 0.7 as best as we could.
And then we did some filtering. I was sort of flagging going ahead. So we have some thresholds. So if someone says he is fond with beer, the model will think, well, of looks really, really good and with looks really, really bad. So let's actually flag that as an error. And conversely, if you have my sister usually gets home by 3 o'clock, well, you can also say around 3 o'clock is pretty good. So the system will back off from flagging that because it just doesn't have enough information to sort of make a claim. So the performance in this was sort of 84% precision, 19% recall. And you kind of look at those numbers and like, that's actually kind of low. If you take like the F-score, let's call it around like F-score of like 40 or whatever. And at least what we did at ETS and what we were told to do was like, we really had to jack up the precision to like around 80 or 90%. Because you don't want to give any false positives to students. So our recall always suffered, but that was sort of on purpose. And some of the metrics in the shared task, they actually optimized for F-score, which is just not the way they would ever work in sort of an educational space. So we would always try to do that kind of number, basically. And some of our typical system errors, given this sort of very basic model, I'll admit that, is just like sometimes the context was just really, really noisy. People can write on a whole bunch of topics. Like we'd have references to specific Islamic mosques that we just never seen in the data, and just didn't have enough examples for those constructions. All right, I know I'm sort of running a little bit low on time, so I'm just going to wrap up. So essay scoring now, it's still like a pretty blossoming community. And like these are the things that I know people at ETS and sort of like in Cambridge and other communities are working in right now. So looking at the organization, the argumentation, people do sentiment analysis for essay scoring. There's now questions that actually ask students to write an essay synthesizing like a speech, they'll listen to something, but also like a written thing where they have differing points of view, and they have to actually proffer their opinion as to which one is right and explain why. So it's not only just a writing task, it's also this sort of synthesis and analysis task. Discourse coherence is one. People work in paraphrase generation, interpretation. There's work on creativity, like people are actually looking to like metaphor identification in essays. And there's some work on better machine learning methods, which are still interpretable. There's also like short answer scoring. So like someone has a question, what's the difference between a mammal and a marsupial? You say, well, one lays eggs and another one doesn't. There's a couple other reasons. But there's all these different ways you actually phrase that, and sort of a classic paraphrase task, and you have to be able to get that right. And so I worked in GEC for many, many years. It was sort of like one of my like big things for like 6 to 8 years. And really kind of like, I try to get people excited in this. And despite 4 shared tasks, performance is still really low. Like the F-score in the last college shared task is like 0.4. And you think about NLP tasks now, like at ACL for like dependency parsing, someone like Mike Collins had a paper that was like 94.02, and like that's really, really, really good. But still, there's like a big gap there. People have tried like machine translation methods, joint parsing, beam search, and you kind of get these incremental improvements. So something big has to kind of jump things up. And now there's a recent sort of focus on evaluation and annotation best practices. There's also work, like a lot of people work in English and NLP, but there's other work doing error correction in sort of Chinese, Arabic, and German. So if you're still interested, have links to the shared tasks. There's a Morgan Claypool book. It's a BEA workshop series. And let's sort of go back to the Yahoo stuff right now. There are summer internships, so if you're interested, talk to me before I leave today. And we offer internships over the summer, or the schedule's adjusted. But basically the goal of an internship, probably similar to a lot of other places, is we want to give you experience working in a company, have a research project that's somewhat related to your dissertation, maybe stretches you a little, but also hopefully gets you a paper out of it, and maybe gets some actual code in production. And we also offer sabbaticals. So Drago Radiv was on sabbatical this past year. Steve Skina from Stony Brook just joined us. We have some postdoc positions, or we have in the past. And another thing is we do offer like web scope data. A lot of people don't know about this. Like Yahoo gives like a lot of data away for free, so you can take a flyer here. So we have a lot of machine learning data sets, a lot of like data sets about like Yahoo properties. Like we have our own Ngram set that's just purely from news. So it's like highly curated. And we have like, if you ever want to work on Yahoo Answers but don't want to scrape the whole site, you can download like 5 years of all the Yahoo Answers. So it's more than anybody should ever need. And there's like millions and millions of question and answer pairs there. And one project I did with my intern last year, Mohammed, was who made an open source, very fast, very accurate, highly configurable dependency parser called the Yara parser. And it's open source, you can just use it for anything. It's in Java. And I told them, like, we're going to make the best documentation ever. I want to be sort of like half asleep on a plane, downloading the plane Wi-Fi, and work on, get this to work on Sigwin. And so it should be able to work pretty easily out of the box. And you can do everything from beam search to dynamic oracles if you want. Anyway, so yeah, thank you.
Questions?
Yes.
I'm curious about the discourse parsing when you're talking about with the automatic essay grading or the sort of like system user partnership. Were you just sort of using like a out of the box discourse parser, this RTS thing? And
RST, yeah.
Was that trained on like GRE or SAC essays?
To my knowledge, no. I think it was trained on the RST tree bank that came out. Like, so that was like Daniel Marcous's thesis. So we had this whole tree bank annotated subsection of the Penn tree bank where they annotated for all these discourse relations. And then he made a parser basically on that that'll kind of go over, segment the text, the text, and actually say, you know, this clause related to this clause with this sort of relation. Like, this is the background, this is elaboration. So I believe like the features that are used there's some that are used to actually identify like this is the main idea, this is the conclusion. And then I believe, I think this is still the case, that they'd actually count up the number of discourse relations. And that was actually highly correlated, especially for the GRE. That's sort of like one of the top features.
They still use that service?
Oh, yeah. I mean, yeah, there's like discourse parsing is now like a hot thing again, like the last year and a half. So there's better discourse parsers. There's one at EMNLP that gets like 80% supposedly. But this one, you know, they have a license. Len.
I was just curious about when we're talking about the latest kind of testing methods in the, I guess for the GREs, does that apply to the GREs?
Mm-hmm.
So the analytical writing, what is used now? I'm just curious because, you know, when I'm on admissions, I always wonder, you know, just exactly what is in these analytical writing things and how are they getting evaluated. They always seem to be in half points. You know, the scores are now from 0, I guess, to
6
5
or
or 6,
something like that.
6, and then they go in sort of half points.
So I left right around the time they were revising it. So it revised around 2012, 2013. So I can't give a good answer for that. Though it's all on the website, so we can actually just Google it during our meeting, basically. But if they're doing the half points, there might be some averaging between the two systems, the human and the computer.
Mm-hmm.
That'd be my guess. And in terms of like the essays, so back in the day, like the essays that we would like work on, they were just like a single prompt and that's it. And now, at least when I heard like what they were doing for the revisions, with that there'd be like a prompt, but there'd be all these variants to the prompt. So you have like a reading passage, and there might be like 5 different questions that could be attached to that reading passage. And you don't know which 5 you get when you actually go into the test.
You mentioned spoken language as well.
Yeah. So there's a test. I'm not sure if it happens in the GRE. I think it happens in the TOEFL. Or it seems like that would actually be a harder thing. So it's probably on the GRE where like the test taker is actually given sort of 2 sources. One is some written passage. Another one is like someone's lecture. So listen to the lecture, read the passage. Not to say like, all right, and it's like differing viewpoints. Like someone might argue like republic is better than democracy, and the other person argues the opposite tact. And they actually have to say like, this is my opinion about which one is better, and here's why, and use evidence for one, and then also like refute the arguments made from the counterpoint.
And that appears in TOEFL, you think?
I think it appears in GRE. I'm saying this like that's too complex for the TOEFL. Yeah. Okay. Well, we can Google that when we go into like your meeting, but. They definitely made it more complex, and like even sort of like they wanted to move away from just like here's a question and just kind of make something up to actually testing kind of the cognitive ability of the student in addition to the sort of writing aspects. So they're kind of loading up more stuff per question.
Mm-hmm.
Yeah. Someone, yes.
When I write something, I make lots of article mistakes, like there shouldn't be a dot. So you see these types of errors in yes.
Oh yeah, all the time. Yeah.
Was there any work on?
Yeah, so that was sort of that was the same model I gave for the prepositions was actually done for the articles, and it works pretty well. So it's a kind of like this is like 10 years ago. So it's like a 2 cascade classifier. Like first determine should an article be there or not. So null or a and or the. Then if you think it's the first one, then you actually kind of like, all right, which of the 3 should I pick? And performance for that, this is like an NLE journal article. was like 50% recall and 90% precision. It's actually sort of like, it's not bad for that kind of thing. A lot better than prepositions anyway.
So do you have a really good mass count distinguisher classifier?
No. Oh, I think.
I've always wanted to get one off the shelf. And never
Yeah. I like my first intern. He was supposed to work on that, and then we just like only had like 8 weeks to pull this off, so we just couldn't collect enough data in time to kind of train something out. But like, that was a very popular error as well that we've seen. Yeah. Yes.
So do you have anything for generation, like essay generation, when you
No.
have all these models?
No, but there's a lot of other people who do. I mean, there's all these stories of like people kind of like making fake kind of academic papers and getting them into these sort of spam conferences, and then and like, guess what? Like, we're gonna go to Florida and make fools of you, and yeah, yeah. But none of this stuff has been used in sort of like a generative fashion at all. And I know every year, like we have like a new hire, and they come in like, oh, what if we did this? It'd be a lot of fun. And like ETS is like, no, don't do that.
Is there any risk of gaming by essay generation? I mean, if somebody develops a system that's trained on each of the topics, you know, that are available in advance, and they push a button on their handheld device.
There would be that risk, because right now it's the ETS. I mean, some of you probably have taken the GRE much more recently than I have, and it's like you go into a room and there's a computer there, and you can't bring anything else, and the computer's not hooked up to the internet, and you just have a screen where you type your essay. Basically, is that pretty much it?
They basically just
Yeah. Okay.
Smartwatches.
Yeah. Yeah. So it's basically like that, though. I remember, like, when I was leaving, there were people talking about, like, what if you could do like tests on the mobile phone and make things more accessible to people? Because like, there's some places like really remote Western China where like getting to a test center is actually kind of a big deal. There's only certain dates you could do it, and they're in like, you know, these kind of very small towns. And so they really wanted to like make things more accessible. Of course, when you do that, there's these huge security reasons, because like people can exactly do that. Like, oh, I see, you know, essay ID 300B, and like I'll just, you know, copy the you know, whatever the essay is over. So I think that's still, ETS is really, really paranoid about anything that could be leaked. I mean, rightfully so. Like, it's a very high stakes exam, so I can't imagine that's going to happen for the GRE or TOEFL anytime soon.
So have they got better security systems than, let's say, the banks and so on that have been broken?
I don't know. I mean, these guys are strip search. Yes.
But I was just thinking that, so like, if there exists a generation system, I bet that it's going to be able to do a really good job, because like there are rules and there are things that you should follow without actually trying to understand language, and which is the problem. Like, I mean, nowadays people just study for TOEFL or like GRE for acing that a specific kind of test, and it just doesn't mean that you're actually a good writer or whatever. So, I mean, do you see like probably ETS like going into trying to understand like the content versus
that's
kind of
a thing, because when you just do the writing quality, I shouldn't say just do the writing quality, so there's like 10 to 12 years of work that got it to be this good. It's sort of like you have to think about like the human side of things. There's always going to be a human grader in the loop. There's other companies that want to do it completely automated, and that's when it gets a little bit dicey, because then people can really go in and game it. At least the sort of human in the loop, you can always have some sort of like check and balance. But yeah, like the content thing is something that they're trying to get going, but that would mean a complete revision to the test, basically. And you have to imagine, if you're a human grader, like if I have to check whether Christopher Columbus came in 1492 or 1592, check the facts and check that stuff, then it starts taking a lot more time.
Right.
That's sort of like the practical application, but I know they've been trying to do a lot of stuff, like at least when I was there, like with LDA and doing like argumentation mining and opinion mining to kind of get these proxies of content without going all the way there. So there's work that's happening. I think there's some work, like maybe Vincent Ng has done a little bit of this as well with one of his students in Texas. Yes.
I know ETS is really for testing, but is there any kind of system which is designed for tutoring? Maybe I type some essay, it tells me exactly which cases, which do I make errors in prepositions
Yeah. So that was sort of like the beginning part of the talk, and it's like there's a thing called criterion, which is basically just sending it to the E-rater system. Instead of like just giving you like a 1 through 6 score, it actually gives you the whole vector of all the different errors, basically. It will sort of flag it on your essay, and you can go and hover over it and give you like helpful messages and stuff. But it doesn't give you the answer. That's the difference between it and Microsoft Works. So sort of the pedagogical theory is that you want to make the person work for it and really learn, all right, this shouldn't be for, all right, maybe it's supposed to be of, and they'll kind of change it, then resubmit and get the feedback whether it's good or not. Yeah.
Okay.
All right, thanks.